Hello mathematicians, we're now going to have a look at the chord of contact. So the chord of contact is defined as the chord which links the 2 points where the tangents from a single point touch the parabola. So if we think about the equation of the tangent at x1 and at x2, then from the work that we just did, the equation of the tangent, this one here, passing through x1, y1, is x1 plus 2a outside of y plus y1. The equation of this tangent here is x2 plus 2a outside of y plus y2. And then, because both of those tangents actually pass through this point, x0, y0, so that's their point of intersection, then x0, y0 must be able to be substituted into each of these equations and make them true. So we have that these two equations are true. But if we look at these two equations, we can see that really x0 appears in both of them and y0 appears in both of them. So what we're really saying is that both x1 and x2 satisfy this equation. And if both x1 and x2 satisfy this equation, then that must be the equation of this line, because both x1, y1 and x2, y2 satisfy the equation of a line which is running between the two of them. Now, we didn't do any calculation there, so this method for the chord of contact is a very elegant approach, and it relies mostly upon thinking. So if we know the point of intersection of the two chords of contact, we can plug that into this expression straight up. We don't have to run through the process of deriving it. So let's have a look at a typical question. Now, we won't do all of these here. Let's just say do part C. Find the equation of the chord of contact of this from each point. So we've got a parabola, x equals 6t, y equals 3t squared, so that means that a is going to equal 3. So we've got a parabola of focal length 3, and from the point 6, 1, which is not on the parabola, so 6, 1 out here somewhere, from that point there will be two tangents, wonky, two tangents which touch the parabola, and we want the equation of the chord of contact, the line which joins the points of intersection of these, without going through the whole process. So we know that in general the equation of the chord of contact is x0, x equals 2a outside of y0 plus y. So x0 is 6, so 6x equals 2a, and a was 3 in this case, so 6 outside of y0, which is 1 plus y. So we've got 6x equals 6y plus 6, or x equals y plus 6. We can choose to write that in whichever form we like. So let's make it y equals x minus 6. So that's the equation of our chord of contact. Now, in question 3, this point lies outside the parabola. Find the equation of the chord of contact from P. So this is the same thing that we've just done. So for our parabola, A is going to equal 2 because 4A equals 8. So the equation of our chord of contact from this point will just be from this equation here, x0, which is 2 times x, so 2x equals 2a, so 2a is going to be 4 outside of y0, which is 0, plus y. So 2x equals 4y, or x equals 2y, or y equals x on 2. So that's the equation of our chord of contact. Find the points of intersection of the chord of contact and the parabola. Well, now that we have the chord of contact, we just want to solve x squared equals 8y and x equals 2y simultaneously. So I've got lots of ways that we can do this. Let's put 2y in here and square it. So we've got 4y squared. Bring the 8y across. 4y squared minus 8y equals 0, which implies that y squared minus 2y equals 0, which implies that y outside of y minus 2 is 0. Therefore, y equals 0 or y equals 2. And for these y values, we work out the x values. So when y is 0, x is going to be 0. Actually, my bad diagram up there is not so hopeless now. So this is one point of intersection. It's at the vertex. And our other point of intersection when y equals 2 is going to be at x squared equals 14. So x is going to equal plus or minus 4. And if we look at our diagram, and given that this parabola is concave up, we're looking at plus 4. And then finally in part C, find the equations of the two tangents. So I'll just look at the technique for one of the tangents, and I'll cheat and I'll do this one slightly more interesting. So the one that goes from 2, 0 to 4, 2. So it's just a straight line joining those 2 points. We find the gradient, so y2 minus y1, 2 minus 0, over x2 minus x1, 4 minus 2. So the gradient is 1, and y minus y1, so if I take 0, that's y minus 0 equals m, which is 1 outside of x minus x1. So this is the equation of one of the tangents, and we would repeat that process with this point here. So have a look at these questions out of 9H. If you think you might want to do extension 2, and if you want to have a play, because that's all it can be at this stage, because you don't have the theory, you might like to have a look at 18 and 19. It's not in there as a test to see whether you're extension 2 material, it's just if you're interested in having a play. Okay.